Hello everyone, I'm Dr. Wang. Here is the question. We want to find the limit of 2 plus h to the power 4 minus 2 to the power 4 over h as h goes to 0. Here, we are going to derive the result in 3 different methods. The first method is the classical method. Use the definition. Here, we need to use the binomial formula to simplify the question. This part, 2 plus h to the power 4. We can use binomial formula to find its expansion. Here is the binomial formula. These combinations, you can use Pascal triangle numbers or use the definition for pick k to derive those constants. The first part is the expansion of the binomial formula. The first term and the last term cancel. We can simplify this part into this part. From this part, you can see the last 3 terms contain h. As h goes to 0, the last 3 terms disappear. The answer is 32. This is the first method. The second method, if we have learned calculus, you can do this way. First of all, look at the limit. As h goes to 0, the first part of the numerator goes to 2 to the power 4. This implies 2 to the power 4 minus 2 to the power 4. This one, the numerator goes to 0. At the same time, denominator goes to 0. This limit is the type of 0 over 0. We have a special name, indeterminate form. We have an important result. L'Hopital's rule. What is the L'Hopital's rule? What are those conditions such that we can use this result? Here's the condition. If limit of f of x as x goes to a equals the limit of g of x as x goes to 0 equals 0. Both limits go to 0. This is the 0 over 0 type. At the same time, if the limit of f prime of x, g prime of x, as x goes to a exists, this means the limit of the ratio of the derivative exists. Then we have the following result. Limit of the ratio of f over g equals the limit of the ratio of derivative f over derivative of g as a goes to 0. This is a very powerful result. If we can use, this should be the most efficient method. Before you use this result, you have to check the condition. If your problem satisfies the condition, otherwise, it is not true. We can use this result now. Limit equals the derivative of the numerator with respect to h over the derivative of the denominator with respect to h. What's the derivative of this part? Take 4 down, 4 times 2 plus h to the power 4 minus 1, which is 3. Derivative of a constant equals 0. Derivative of h equals 1. Right now, we can replace h by 0. We have the following result: 4 times 2 to the power 3, which is 8. 4 times 8, 32. Again, we have the same result, 32. The last method, we consider this limit as a derivative from the original definition of a derivative. This is the definition of f of x when x goes to 0, f of c plus h minus f of c divided by h. This is the definition of the derivative of f at point C. So here in our situation, what is f? F is this part, this part. What is c? C is 2. This is f. F equals x to the power 4. C equals 2. So this part is the derivative of f at point C, at point 2. F equals x to the power 4. What is f prime? Equals 4 times x to the power 3. We are ready to derive the derivative. By definition, we know our limit equals f prime of 2. What is f prime? F prime equals 4 times 2 to the power 3, which is 32 again. That's all. Thanks for watching and see you next time.